Okay, so in the last video, I introduced you guys to the idea of slope and that pattern that arises in linear functions, the slope, that constant rate of change. So now I'm going to show you how to graph using slope-intercept, which is easily the fastest way to graph a line if your line is in that slope-intercept form. So again, that slope-intercept form is y is equal to mx plus b, where b is going to give you your y-intercept and the m is your slope. So our example here that we have, we can see already our slope is negative 2 over 5, and we're just going to use m to write about that. And our y-intercept is positive 3. And that y-intercept is what happens when I plug in 0 for x, because if we plug in 0, that whole term is going to go to 0, and then that's all that's going to be left. So we can start by putting in our y-intercept, 1, 2, 3, 1, 2, 3. Right? And it's going to be the intercept on the y, so we're always, whatever number is here, it's going to tell us exactly where we would like to throw that on our graph, on the y-intercept. Oops, went one too far. And then we're going to use our slope to do the rest of the work here. So our slope, if we look at that, we have negative 2 over 5. The negative could be out in front, could be on the bottom. I wanted to show that really quick. So negative 2/5 is the same thing as negative 2 over 5. It's also the same thing as 2 over negative 5, so it's up to you. Now remember, our slope gives us rise over run. So if we have a negative 2 on the top, instead of going up 2 and rising 2, we're going to go down 2. And we're going to run or go right 5. So negative in the y direction 2, positive in the x direction 5. So down 2, 1, 2, right 5, 1, 2, 3, 4, 5. So that's a point on our graph. And we can do that as many times as we want. 1, 2, 1, 2, 3, 4. Right? We can keep finding points and points and points. And it's really nice, especially for those of us who aren't carrying around a ruler, to have a bunch of points when we go to sketch our line through it. We can also go the other way. This negative can go on into the denominator. In this case, we would go up 2 and then left in the negative direction for the x's, 5. So same thing, up 2, 1, 2, 3, 4, 5 in the other direction. And you can see how that point is also falling directly on our line. And then we can just connect those all with a nice straight line, arrows on both sides to say this keeps going forever and ever and ever, and all the points in between those points exist as well. So that's graphing using the slope-intercept. What are the only other things that can happen with this? Well, one thing that can happen is we could have a question like this. Y is equal to 5x minus 3. So here in this case, we can pull off our two pieces. Our slope is 5, and our y-intercept, our b, is equal to negative 3. So let's get those things on a graph. Our y-intercept is a point at negative 3. Our slope, the only thing that can be tricky about this is that when there's just one number, it's hard to see the rise over run. But 5 is the same thing as 5 over 1, right? So we now have our rise and our run. We can go up 5 and to the right 1, positive direction for both. If for some reason this didn't work, we can also go negative 5, negative 1, right? Because negative divided by negative is just positive 5. This is just a hideous way to write negative 5. So we could also go down 5 and left 1. Also completely okay. So I'm going to go ahead and do the up 5, right 1, 1, 2, 3, 4, 5. So I've got my plus 5 in the positive direction, and then right 1. Right? I can even draw myself like a little triangle to find my next point. And then I do the same thing. Up 5 over 1. Assume I actually have points, axes labels, so that we can see that that's 5. I didn't just draw something that was the same size. And then when you're finished and you've got enough of them that you feel comfortable, draw a line not off of them, like I just did, but draw a line through them. Boop, boop. And you're done. That's it. Slope-intercept form is, I think, the easiest one to deal with. So I'm going to go ahead and give you guys just one more if you want to try it. So if you want to, go ahead and pause your video now after you see the question, I guess. Pause the video and try out something. I don't know. What do we want to do? Let's do 1 over 3x plus 5. Okay, so try it out. Figure out how exactly you're going to graph that. I'm going to go ahead and add tick marks. Okay, I don't know why I paused, because you should have paused your video. Whatever. So we put our y-intercept in first at positive 5. And then we're going to use our slope to find the next spot. So we're going to go up 1 over 3 to find our next. Up 1 over 3. Up 1 over 3. Again and again. If we wanted to go down 1, we could go left 3. Assume I counted 3 there. And then we could connect all of this with a beautiful slope, right? Or just a beautiful line. So, like I said, I think the most common mistake that students make, for whether we're doing the intercept version of graphing a line, whether we're doing the slope-intercept version of graphing a line, is that they end up doing weird things with going in the wrong direction. So just generally keep in mind that if we have a positive slope, we should see what happens in a good bank account, right? Things growing. This is a positive slope, a slope that is greater than 0. If we have a negative slope, we should see things doing what we don't want to see in a bank account, plummeting, right? So this would be a negative slope. You can even go a little bit further. I happen to draw both of these lines with slopes about 1. This is about a steepness of 1. So is this. It's like a steepness of 1 on the negative side. So if you have something that is like this, oops, 1/3, 1/3 is less than 1. So what we should have, and what we do see here, is that we have a line that is less steep than a line would be if it was perfectly through. That's not even perfect, but halfway through, so more like this through our thing. So since it's less steep, we have a smaller slope, because again, slope just measures the steepness of your line. So that's graphing with slope-intercept form. That's it.